Mr. Beacon podcast is sponsored by Wiliot, scaling IoT with battery-free Bluetooth.
Welcome everyone to the Mr. Beacon podcast. I am really delighted to have Marco Palladino, who's the CTO and co-founder of Kong, as our guest this week. Marco, welcome.
Thank you, Steve. Thanks for having me here.
Must be kind of a strange time for you now. We're kind of starting to ramp up, and Italy had that terrible experience. Actually, our director of product management is Italian. He's going back to see his family. But, because we're this hotspot here in America, he has to go into quarantine for 2 weeks to go back. So how is it all impacting Kong, this virus thing?
Well, so first and foremost, it is a very sad global situation. I still have family in Italy. Italy was hit earlier into this pandemic. It seems like the country is recovering right now. The US now is in bad shape. So what Italy was facing back in the days a few months ago, we're facing it here now in the United States. It's sad, however you look at it. So I hope that everybody will come out stronger out of this. From a business standpoint, two things have happened. The first reaction when there is something like this happening in the world is fear. And so the first instinct for everybody in the industry and the users and the customers we're working with was fear. What's going to happen? What's going to change? And usually fear. They say fear, it's an emotion even stronger than love, in a sense that, it paralyzes you in a way that slows things down. But then soon afterwards, it was clear that in this world, and if there is a new world emerging out of this, it is certainly going to be a digital world. And so organizations who were ready to address the digital challenges in a digital world where everybody's using their digital devices and nobody can meet in person anymore. The companies that were ready are the ones that are winning. The companies the organizations that were behind in their digital transformations are the ones that are suffering right now. And so the second thing that happened is an acceleration of the digital transformation projects that these organizations were implementing. They accelerated it because this was a great trigger for them to speed things up.
Yeah, I guess if the goal is agility, if the goal is manage your resources better, your supply chain, your assets, whatever, the services you're delivering to customers, now is the time to optimize and get efficient. And that means very often moving forward with your project. So are you seeing, did you see like a down spike in revenue and then an increase, or what does it mean from a business perspective?
We saw the first couple of weeks, kind of a slowdown, because everybody's trying to figure out what would happen. And then, we're working with organizations that either already wanted to transform digitally, or they were already in the process of doing that, or they've already done it and they want to increase efficiency. And so with the kind of customers that we're working with, what we saw was a couple of weeks of, what's going to happen? And then immediately afterwards, okay, let's do this. Let's do it quick. Because if we don't do it, we're going to be out of business. And so they look at Kong and what we provide as, they look at us as partners in their digital transformation, which has been great so far. So, revenue and the momentum has definitely accelerated in the past few months.
Well, normally we talk about radio technology and stuff that's very low down the stack, but I've always believed in taking a holistic view of solutions, and the cloud is an area which I want to learn more about. I grew up, did my computer science degree in the 80s, so I was doing assembly language programming, COBOL and C. And, these apps were huge, monolithic things. And I thought we were moving forward when we had client server and load balancers. But your company is thriving, and you're really rock stars in this serverless computing API, container-based world. And what I'd like to do in the show today is have you kind of give us a bit of a masterclass around some discussions and questions I had about the fundamentals of that technology. But before we get into that and start picking your brains, I'd love you to tell us a little bit more about Kong. It's an amazing company. I had the pleasure of going to your developer conference last year. I'm really going to miss, I'm assuming you're not having a face-to-face developer conference this year.
Not this year, but we're having a digital one the first week of October, Kong Summit.
Well, last year's was amazing. Some really large enterprises, Cargill and GE, talking about how they're moving towards this more agile, efficient framework, and also having donuts on door hooks was just an amazing thing. So it was very fun, great culture, a great company, and you have got some amazing investors, Andreessen Horowitz, you've got Jeff Bezos, Eric Schmidt. How did you get from Italy to San Francisco? And tell us a bit about the history of the company and how you got such amazing investors. And I guess also I'm fascinated by, you've built a massive community around what you're doing in the open source space. So I'd love to hear about that. But let's start at the beginning. How did this all get started? How did you and your co-founders meet and get started?
Yes, me and my co-founder, Augusto, we met in Milano in our early 20s through common friends. And, we started a business in Italy. We sold it. But as you know, Italy is not really the right place to build a technology company. I'm a big believer that, of course, you have to be in the right place at the right time. And sure, if we want to start a food business or a fashion business, we'll probably move to Italy. But if we want to start a technology business, we need to go somewhere else. And Silicon Valley and San Francisco certainly is that kind of place. And so, we were in our early 20s. We didn't have much money around. So, everybody asks me, how did you end up in San Francisco? Well, quite frankly, I just drove to the airport and took a plane. And so we landed in San Francisco with money to stay here and survive only for 1 week. But the return flight was 3 months later. So as soon as we landed, we had to ask for help quite immediately. And we start emailing people and, asking for help to, we're not from here. We didn't know anybody here. So we had to build our network from scratch. And this entrepreneur back then, he answered to our call for help. And he said, if you guys want to stay at my place for a few weeks, you guys can sleep at my place. And, I was talking to my co-founder. I'm like, should we go to this guy's place? We don't know this guy. Is it dangerous? I don't know. But do we have money? No. So we have to go. So this guy was Travis Kalanick before he started Uber. He sold Red Swoosh back then. And then, he was, in between selling Red Swoosh and starting Uber, he was helping entrepreneurs. And so it was us and other folks. He helped us, get introduced into the network. We signed our first angel round on his kitchen counter in San Francisco. And that's how it started, really. We built our first product. We raised the first money. We got the first customers. But the idea was different. When we moved to San Francisco back then, the idea was not to start an API management business or a connectivity business. The business was to do something else. So we came to the US with a company called Mashape. So Mashape was an API marketplace, which ended up being the largest API marketplace in the world. Developers could consume APIs and publish APIs that others have built. And the idea really behind this vision was the realization that APIs are a third industrial revolution in this world. Like the first industrial revolutions, we assembled together different components to build an assembly line, really, and build cars and build fridges and build, appliances. APIs are the assembly line of software. We can take APIs that somebody else has built from within the organization, from outside of the organization, and assemble it together to create new software. So Mashape was this marketplace where developers could publish APIs and sell APIs and consume APIs to build software in a faster way. And those were the years where we started to see API-only companies growing up for the first time, like Twilio, right? And that was incredible to see. Now, turns out that we transitioned to microservices quite early in our journey. And we needed to build an API gateway that was powering all of these APIs that about 300,000 developers at the time were publishing and consuming on top of Mesh-Ape. And Mesh-Ape had an ape logo because it was Mesh-Ape. And so what's the most famous ape in the world?
King Kong.
King Kong. And so we called the gateway Kong, and we built it for ourselves. We open sourced many things back then, and we open source Kong as well. So it turns out that our transition to microservices and the requirement of a very fast, lightweight, distributed gateway that we built for ourselves first and foremost was something that everybody else needed as they transitioned to microservices. So we open source Kong. All of a sudden, Kong just explodes in adoption. Developers from all over the world, organizations asking us for enterprise support and enterprise features, to a point where we decided to divest the API marketplace and fully focus on Kong. So Mesh-Ape Inc. became Kong Inc. And that's how we are now with the current company. Kong now, it's much more than just the gateway, but that's how it all started.
So if I'm a developer and I want to get into business and I find an API that I think the world needs, I write it. I can still go to Kong and use that marketplace to make it available to others, or not?
Well, it turns out that the marketplace was growing from a user standpoint, but not as fast from a revenue standpoint. And we can talk about that. Monetizing the long tail of developers, it's a very complicated thing to do in this business. But long story short, the number of users was growing, the number of APIs was growing, but big problem, the number of the revenue was not growing as fast. So we decided to fully focus on Kong and sell the marketplace to another company so that we could focus on building the infrastructure, the next generation infrastructure layer for any organization out there who wanted to become an API first company or an API oriented company.
So you had a lot of developers, a lot of APIs on the ecosystem. Can you remind me again how many at its peak with Mesh-Ape?
With Mesh-Ape, we had 300,000 developers and tens of thousands of APIs that were all being processed by Kong. And we transitioned to Kong. We open sourced Kong in April 2015. And the company transitioned to Kong Inc. in 2017. You
saw these 300,000 developers, tens of thousands of APIs, and they had a need. They were selling APIs, but they needed a gateway and infrastructure. I'm interested in two things. One is just to understand a bit more about these APIs, and if you had to analyze them, I mean, many different APIs, but what were the clusters of functionality that people were implementing with these APIs?
So let's take a step back. Let's look at why people need something like this. As we know, every business is becoming digital, right? And every business, everything is digital. Everything is going to be offered via applications that people can access from pretty much any device, including IoT, including everything else, right? And when something becomes digital, the most important thing to do is to make sure that the applications are reliable. So as a second step, organizations that have a digital strategy, they're going to be improving the reliability of their applications by distributing them, by decoupling the applications so that they can deploy faster, they can improve things faster, they can scale the team in a faster way. When they become distributed and when they become decoupled, as a result to that, they introduce APIs. APIs are an essential component for any reliable, decoupled, distributed application that anybody's building in the world, no matter what industry that is. It can be finance, can be banking, can be traveling. And APIs, they bring a set of concerns that we do not have in a traditional monolith that doesn't have APIs internally, network APIs. And those concerns are pretty much around connectivity. So once we have an API that goes over the network, the biggest problem is that we have the network, and the network is unreliable by default. So how do we secure the network? How do we make it reliable? How do we observe the network? How do we encrypt the network? And then once we do all of that, how do we expose our APIs over the network so that somebody else, a developer, a partner, an internal team, can then consume the API? All of this tooling is tooling that traditionally the application teams were building. So the application teams were building the applications, they were distributing the applications, and as part of that effort, they were also starting to manage the network. quite frankly, managing the network should not be their job. So what happens is, the more applications we have, the more services we have, and the more fragmentation we have, because each team is basically reinventing the wheel when it comes to all of these APIs that are created. So instead of reinventing the wheel and building it from scratch every time we introduce a new programming language or every time we introduce a new application, how about we delegate all of this to a third-party component? And that third-party component can either be an API gateway or can be a service mesh, depending on the use case where we operate in. And so really, when we built the gateway for MashShape, literally, we built it for ourselves. We had a microservices-oriented architecture to run the marketplace internally. So we had a service that was dealing with the building, a service that was dealing with the user management, a service that was dealing with, all the different aspects of running a marketplace. And we needed to have a gateway internally that was fast, that was quick, that could glue all of this together without us having to reinvent the wheel. Turns out that what we built for ourselves, it's something that everybody else needs to build when they transition to APIs and when they transition to microservices. And especially after 2013 and 2014, in the industry, there was quite of a market transition with Docker and Kubernetes in such a way that everybody can now transition to microservices without having to build from scratch the building blocks. And so they use containers like Docker to package their software. They use Kubernetes to abstract away the operations of their data centers. But what do they use to abstract away the connectivity that their applications are generating? And they're coming to us, to Kong, to abstract it away from everything that they're building and then manage it in an organized way, in a reliable way.
So you've covered a lot. I want to go back and tweeze apart a few things, explain a few things, have you explain a few things on what you've said. But what I saw at your conference was there was a lot of very large enterprises I'm just kind of looking at your customer list. You have like Deutsche Telekom, Orange, Cisco, NASDAQ, GlaxoSmithKline, Beecham. So how much of what you're doing with them is part of an exercise where they're trying to take monolithic legacy applications and break them up so that they can have some of the benefits that we'll get to of doing that? And how much of it is facilitating businesses that want to sell services, whatever it is, a commerce service or an inventory service for third parties. And I guess maybe I'm also interested in the degree to which you're seeing those very large companies not just break down what they're doing for efficiency, but open up what they're doing and change what they're doing and kind of essentially getting into the API business. That's a lot in a question, but
organizations are moving away from monolithic applications to get all the efficiencies that we just spoke about. So that's obviously one major motion that we're seeing across our customer base. As soon as they become microservices, as soon as they transition to microservices, they introduce APIs. And so how do we manage all of that? So that's one aspect of it. But then there is a significant part of our customers that are providing those APIs to either external developers, to partners, to mobile applications, to even IoT use cases. We connect with Kong, 20 million cars in China. We connect with Kong, trains and ticketing systems. When there is a pre-flight checks on a plane that the pilots are doing, that system is powered by Kong. So there is lots of IoT going on there as well. And it's all over the case. It's all over the place. And so connectivity that we're offering at the edge, connectivity that we're managing internally, connectivity that has to be distributed across the world in order to be able to power IoT devices. All of the above is being implemented in one way or another by the customer base. And quite frankly, these as a founder, this is really what keeps me, what makes me excited about, waking up in the morning and going to work, because I know that the entire world economy is, if it's not running on API already, it is definitely going to be running fully on APIs, and the market opportunity for Kong is great, and Kong runs the real world, and that's really what makes me excited.
Yeah, I mean, you're changing the world, and that's an exciting thing. You're changing the way these massive companies to business. What I was trying to get a sense of is to what degree are they doing what they're doing for robustness, scalability, availability, and agility, or are they fundamentally changing their business models, and are they exposing what they're doing to their customers through a world of APIs?
Yeah, so they're transforming the existing business to be API powered. So APIs certainly unleash new creative ways of APIs provide building blocks that we can then assemble, like I said, in an assembly line, basically, to provide new revenue streams and new products in an easier way. But first and foremost, they're using APIs to transform and digitalize the existing business, the business where the money is being generated today. Then as they do that, that creates an opportunity to create new products in a faster and easier way. Because if the core business is API-fied or AP-fied, or it's offered via APIs, then it's easier to build a whole ecosystem around that in a much quicker way.
Okay, I get it. Very good. I'd like to get into a bit more some of the terms that those of us who aren't at the center of this hear and kind of understand what they mean. I'm just thinking, do we need to spend any more time on why people are doing this? It's probably worth just one last run at that. So in the past, we had these monolithic applications. You had companies like F5 that were allowing people to have multiple instances of that monolithic application. But I think what you're enabling is more decomposition of those applications. And how do you advise people, if I am a company that's making food products and that sort of thing, and I have all these massive systems, how do they go about taking a legacy application and breaking it up into this new service containerized API-driven system?
But usually organizations decouple their monoliths into microservices using primarily three different strategies. One of them is what I call the ice cream scoop strategy. So when you have a big ice cream box, what do? You scoop out different services out of your monolith little by little, and you connect them together. So you don't do it all at once. You do it slowly over time, which in my opinion has been one of the most successful ways to transition a monolith into microservices. Doing it gradually and doing it by providing business value immediately to the organization usually creates confidence within the team that this is the right way of proceeding, and also gives confidence to the management of the organization that transition to microservices is effectively something they should be doing. Some other organizations, instead, they keep the monoliths where they are and they build new applications in a microservice-oriented architecture, and then they glue them together, they connect them together with the monoliths, and they do that in a couple of ways. Either they create a set of APIs on top of the monolith that they will integrate with these new greenfield microservices applications, or they transition to event-based microservices. So they use events managed by a log collector, like RabbitMQ, Kafka, or Amazon SQS, or whatever that is, to glue together the monolith and this new greenfield. So there's a couple of ways we can connect a greenfield with a brownfield. And then there is a set of organizations, very few of them, that decided to transition using the nuclear strategy, which is we're going to be removing everything and rewriting everything from scratch, and it's going to be microservice oriented. Very, very waterfall oriented. I have not seen that happening a lot, but I've seen it. Mm-hmm. And usually if the application is too large and too big, this is not the right approach. And There's a lot of excitement about rewriting everything, because that's what engineers like to do, rewrite and thinking of better ways of building our software. But usually the business suffers from this kind of decisions. The ice cream scoop strategy, slowly decoupling the monolith, the most painful parts of the monoliths into separate microservices. Usually that's the biggest and the most successful strategy that I've seen.
I see. Yeah, this is interesting. I love the ice cream scoop metaphor. And you also talk about pizza teams. There seems to be a theme here. What's a pizza team?
One of the reasons why we're decoupling monoliths to microservices is to be able to innovate faster, build faster, deploy faster. With a monolith, we deploy once every week, once every month, whatever that is, but we want to deploy 50 times a day. We want to deploy 100 times a day. So the monoliths, it's not the right architecture for that kind of velocity. So we transition to microservices so that we can build features faster, so we can fix things faster. As we transition, as we decouple and distribute our software into microservices, well, we also decouple and distribute the teams that are building those microservices, because now we don't have a large team that's dealing with this huge code base anymore, but we have individual teams that are dedicated to maintaining and improving and building separated concerns, separated microservices among the greater picture. And a pizza team is a concept that's quite funny. Basically, a pizza team is a team that's as big, it's not more than 7-8 people, because ideally you can feed them all with a large pizza box, right? With a large pepperoni, you feed your entire team. So we have these small decoupled teams that are working on decoupled concerns, and all of these teams are talking to each other via an API that even internally has to be connected, has to be secured, has to be improved, and so on and so forth, documented, and so on and so forth.
So this, I was always intrigued by this idea of continuous deployment, and I guess you break things up and you don't have the monolithic. If you don't have a monolithic app, you don't have to do the monolithic transition to the new version of the app. I'd love to hear a bit more about that. What is a blue-green deployment, for instance? Is that part of this?
When we release a new version of any service, we want to be careful that the new version we built actually works well. And so blue-green or canary deployments are strategies that we can implement in order to be able to shift not all of the traffic all at once to the new service by slowly migrating the traffic. So if there is something that's not working properly, that has not been cut up in our tests or integrations to it, we can quickly revert back without affecting the entire customer base. Now with blue-green deployments, it's a very simple concept. So we create a new replica of the new version of the service we want to deploy, and then with the load balancer, we tell the load balancer, stop pointing at the old version of the services, start pointing at the new ones, right? And with Canary, we do the same thing, but we do it with small increases of traffic every time. So we transition 10% of the traffic, everything seems to be working again. Fine, let's increase to 20%. Everything works? Okay, fine, then 30%. And so over the course of a time window that you can specify, you can then shift the traffic towards the new version. But if anything at any point in time goes wrong, we can revert back, right? So we can go back to the old version until we fix the new problem that has emerged in the new version. All of this are just some of the things we have to think about when we move to microservices. Deployments is one aspect of them. Observability and how we trace and monitor and log all of this is another one. Like in a monolith, if we have a monolith and there is a bug, the monolith gives us a stack trace, which tells us exactly where the problem was. But in a microservice-oriented architecture, the problem may not be in our service, maybe in somebody else's service that somebody else has been building, perhaps in a different language. So how do we know where things go wrong in a microservice-oriented architecture? We need to have an end-to-end trace that tells us exactly where things go wrong. And that's required if you want to move to microservices. So tracing, security, deployment, versioning, chaos engineering, all of these are aspects that we have to build and implement when we transition to microservices. Then, of course, we don't have to build it from scratch. That's why companies like Kong come into the picture. Us, like many other organizations that are trying to innovate in the infrastructure space, we tell developers, don't build that by yourself, but use something that we've already built that we think is going to be a good fit for you, so that you can focus on building the service, focus on building the application, and everything else comes out of the box. That connectivity, that security, that deployment strategy, all of that comes out of the box.
Interesting. So I think what you were describing there is an example where a microservice, you're going from one version of the microservice to another version. So maybe the microservice is a caching system, or I don't know, an authentication system. What about multiple services being transitioned concurrently? Is there a kind of a framework or rules or best practice on how to do that? Because your application may be made up of hundreds of different services, and presumably you don't want to necessarily, is best practice to change one at a time, or how do you coordinate multiple transitions?
This is a very interesting question. Like every transformation, the transformation to microservices also involves three different aspects. One of them is the technology aspect. Okay, we're going to use Kubernetes, microservices, and that's what we spoke about up until now. And then the second thing that we're going to be changing in how the people are being organized to build this software, and we address that. And the question you just asked touches on the third thing that every transformation brings to the table, and that is culture. Culturally, when we run a microservice-oriented architecture that's distributed, that's decoupled, we have to live with the fact that our system is always going to run in a partially degraded way. So there's going to be teams that are isolated from each other, making upgrades simultaneously in an isolated way. And all that we know is that as long as the API doesn't change, we don't care about implementation changes on their end. So as long as the API keeps working, we don't care what they change. And it is very important that as all of these happens simultaneously, there's lots of moving parts, there's lots of benefits, but on the other end, there's also lots of moving parts. As all of this happens, it's very important that the APIs are not being disrupted. And that's all, that the interface, it's not being disrupted. So as long as the interface is not being disrupted, multiple teams can make multiple changes at the same time, and everything will keep working together. But yes, if somebody makes a change that breaks the API, well, that will cause big problems. Now we have to revert back to the previous version of that API, because we're not, there are migration strategies we have to put in place to make sure that every other team upgrades to a new version of an API in case we need to make a breaking change in the API.
So we have
And that's why designing an API, it's not something that should be taken lightly. But thinking about how the API, many people build APIs focusing on what they want the API to do today, but they don't think about what the API should be doing tomorrow.
Mm-hmm.
Building an API that can support changes over time without being disruptive of existing clients that are consuming it, it is one of the most important things that an API developer should be doing.
I want to go back to this thing that you touched on just now about the organizational aspect. So I see we have these pizza-sized teams that are developing these services. They're not reinventing the wheel. They can use API gateways, and they can use some tools like Docker and Kubernetes, which I want to go back into those and explain to people what those are. But on the organizational side, it seems like there's a very important team, the DevOps team. Are they the ones that are kind of accountable for the orchestration of these changes? Or explain to me where DevOps came from. DevOps didn't exist when I started programming. So what happened? Where did they come in? What do they do?
So the application teams that are in charge of building the applications, they need to be able to work very well with an infrastructure team that provisions the resources they need in order to run the applications they're building. we don't want the application teams to worry about infrastructure. Because if they did build the infrastructure in addition to building the applications, we would have a different infrastructure for every different application. So we don't want that. We want to be able to tell the application teams, use whatever language you want, use whatever framework you want, do what you want when it comes to the application code base. But when it comes to deploying it, when it comes to securing it, when it comes to offering that connectivity, when it comes to running it even, do not build that infrastructure by yourself, but ask for an infrastructure developer or an architecture team to provision that for you. Likewise, in the good old days, we were provisioning hardware in the data center. We're building a new app. I need 5 racks so I can run my application. Very similar concept, except the infrastructure is digital now. So I need 3 Kubernetes clusters running in these 3 different regions, and I need a service mesh. Please provision me this as I build the app and I deploy it on top of that infrastructure. Now, once the infrastructure is being deployed and provisioned by an infrastructure team, the application teams not only has to run the application, but they also need to be able to upgrade it and version it and do deployments. And then when it comes to the operations, there is 2 different approaches the organization can take. They can still keep the infrastructure team as the gatekeeper of what changes are happening, but that risks making the infrastructure team a bottleneck, because every change the application team needs to make when it comes to rerouting the requests now goes through the infrastructure team, which is going to be kind of a bottleneck into making sure that everything is fast and quick. Or the application team has a degree of freedom that they can use to operate on top of the infrastructure that has been already provisioned by the infrastructure team, which in my opinion, when done right, it's the best approach. So what the infrastructure developer will provision the infrastructure, and it will create role-based access control rules to give permissions to the teams to be able to do certain things in the day-to-day of their operations that do not involve having to ask for anybody else to do it for them. But fundamentally, the person in charge of maintaining this infrastructure is not the application team, it's the infrastructure team or the architecture team or the platform team, however you want to call it.
So I want to go back and do a sort of quick 101 review on some of the terms that you were using earlier. So you talked about Kubernetes. Can you tell us a bit about the origin of that? What is it? Where does the name come from? Where was it developed? What's its role?
You see, transitioning to microservices, it's something that we're hearing today, but the concept per se, it's actually quite old, perhaps even more than a decade old. The reason why we're hearing it today, it's because today this pattern is more accessible to more people, thanks to Kubernetes and thanks to open source technologies that have been released in the meanwhile. But when we talk about microservices in general, it's a very in technological terms, it's a very old concept. Companies like Netflix, like Amazon, like Google, they've transitioned to microservices before anybody else even starts speaking about microservices. But in order to do that, they had to build their own tooling. So they, when you transition to microservices, we want to have a way to package our software in a standardized way, a way to deploy our software in a standardized way, a way to, do all of these operations in a standardized way. So prior to Docker, prior to Kubernetes, these organizations internally with their R&D teams, they built their internal tooling to be able to do this. One of these companies, Google, decided to adapt one of their internal systems called Borg into, Borg was very Google oriented and very Google specific. So they decided to take the same concept, but abstract it away from the Google internals and offer it to everybody else. And that happened after a company called Docker created a standardized way to package our software. When we look at Docker containers, basically it's like if I had to take 1,000 steps back, it's like looking at an archive, a zip file or a tar file that ships with the application and the operating system. So there is a standardized way to deploy our software, and then there is a standardized way to run this packaged software around. And it's not far-fetched to think of containers and Kubernetes with the real-world analogy of ships, containers, and container ships and the actual containers that we use for our merchandise and the global shipment business in the world. It's a standardized way to put everything together in the same shape and form, and then it's a standardized way to build chips or the underlying infrastructure that allows us to carry these workloads from one place to another. Similar concept as the real world, ships and containers, but adapted to the software world. And so Docker created this new way of packaging the software. Actually, Docker created an API that was wrapping around a technology that was available since a long time, and that was LXC in Linux world. So they created a nice and easier to use API to make container technology more accessible in the world. And Kubernetes released a way of being able to easily deploy it and run operations on top of these containers. And all of a sudden, the entire world doesn't have to rebuild their own container system and their own orchestration system, but all of a sudden they can use existing technologies in the open source ecosystem, self-service, to build and transition to microservices. So the revolution that Docker and Kubernetes have done was to make these technologies easily accessible to the rest of the world. And I have to say that open source has been a driving force into this new market transition that is defining how we're building digital applications today. Open source, Docker is open source, Kubernetes is open source, even Kong is open source, Prometheus, Grafana, open source, Jaeger, Zipking, open source. Open source is the driving force behind modern infrastructure. There is no modern infrastructure without open source.
Makes sense. So Kubernetes, I think there's like some Greek in there, something to do with pilots or guiding or orchestrating. I can't remember the origins, but you have these containers of software. I kind of think of make files from the old day of how do you extract and deploy the software. Is Kubernetes doing load balancing, failover? Where does that fit in this architecture?
Kubernetes provides primitives that we can use for service discovery, for load balancing, for all sorts of things. But I guess the biggest benefit that Kubernetes provides is being able to, first and foremost, being able to make many virtual machines look as if they were one computer. So when we deploy our software, Kubernetes deals with the orchestrating where the workload is going to run on what underlying virtual machine. But when we deal with Kubernetes, we use the Kubernetes API, and Kubernetes abstracts away the underlying virtual machine landscape. So Kubernetes allows us to build a very large computer that runs in a distributed way. That's one innovation of Kubernetes. And because it's being adopted by all the major clouds, the second advantage of Kubernetes is that it defies vendor lock-in or cloud lock-in. We can build something for Kubernetes, and it can run as well as on Amazon, as well as on Microsoft Azure, as well as GCP. We can move it around. As a matter of fact, we can also run it in our own data center if we have a Kubernetes instance running somewhere. So these are the two main benefits of Kubernetes. It provides a few primitives out of the box that allows us to create a modern infrastructure that can be used to deploy services, connect them together, load balance them together, deploy them together, and so on and so forth. Now, these primitives per se, they're not super intuitive for many people out there. So Kubernetes is the technology that any organization wants to use to build an internal platform as a service that they give then to the application teams. The application teams, I don't know if you're familiar with Heroku. Heroku was a very innovative back in the days because you just git push your code and somehow, somewhere, that code would be deployed. What infrastructure teams or platform teams in every enterprise organization should be doing is using Kubernetes as a framework to build a PaaS that they offer to their internal teams, right? But we definitely do not want the application teams to directly mess with Kubernetes, because Kubernetes, although it's very simple, it simplifies a lot of things. It can still be quite hard to grasp for people that have no experience with it.
So the fact that Kubernetes is available on Microsoft and Amazon and Google Cloud Services is appealing. What's your view on the customers that you see, their ability to span those platforms. No one wants to be locked in. I went to the Amazon developer conference last year, and it was frightening. It was frighteningly large. I mean, it was just a sea of armies and armies of people. And I'm, wondering, to what degree are these people trapped in the AWS land, and to what degree are they ever going to be able to switch? Are you seeing, is that elusive? Are people building for cross-platform independence, or do you just have to give it up and say, no, I'm going to kind of get addicted to these very compelling APIs that they offer that only run on one platform or the other?
And this question reconnects to my statement I made a few minutes ago. Modern infrastructure is open source, because if we use open source software, some vendors, they may offer an open source as a service, right, in each respective cloud. But if we ever wanted to move away from a cloud vendor and we use open source software, then we can use any other as a service version of that same software in any other cloud. And that's why open source is the driving factor of modern infrastructure. And quite frankly, I don't think cloud vendors like this. Because cloud vendors, they're going to be providing higher and higher level services in order to be able to, and we're seeing this all around, even in Kubernetes land, we're seeing that cloud vendors are extending Kubernetes to provide more features, more functions, hoping that, where we're not going to be moving to any other cloud vendor as long as we keep using those features that are not open source. And so, organizations today, it's not a matter of if. Organizations today are already multi-cloud. A specific product, a specific team may not be multi-cloud because they decide to run on Amazon or Google or Azure, but from a holistic standpoint, the organization per se, it is multi-cloud today, not because it wants to, because it has to. Different lines of businesses, different teams, different products. Some of these are coming out of acquisitions. Some of these are using very specific services that the cloud vendors are providing. Every large organization in the world is multi-cloud. So I don't think that multi-cloud is something that the application team has to worry about, because rarely an application team, it still happens, but rarely an application teams will decouple their workloads across multiple clouds simultaneously, although it does happen. The multi-cloud concern, it's a concern of the platform team who is provisioning infrastructure for every line of business and every team in the organization. And those are the guys that are going to be dealing with all of these different variety of environments. And so the reason why, even Kong and Kuma, the service mesh that, we're contributing to, all of these are platform agnostic. It's because our user is not the application team. Our user is the platform team. And that user has to deal with a multi-cloud reality.
Well, I realize it's pretty much the top of the hour. Do we have time for one more question? I just wanted to ask you where this is all headed, and it's an open question, but I'd be interested in your thoughts.
Maybe to Mars, where we can listen, where we can, and everybody's going to be listening to the three songs I mentioned before. No, I don't know. At the end of the day, we are transforming to the main driver to any transformation is the business. We want to improve our business. We want to make existing customers happier. We want to target new customers. We want to increase our total addressable market. And to do that, we transform our organization, we transform our products in order to be able to address the challenges that we're being presented with as we try to drive more business. The business is always the main driver. So we're going to be doing whatever it takes to make sure that we can provide reliable platforms and reliable experiences at the lower cost with the maximum efficiencies in the best way possible. Today, for some organizations, that means moving to microservices. For some others, means to move to serverless. For some others, means to adopt all of these different patterns. Where are we going next? We're going to whatever is the last, the path with the last resistance and the less friction that allows us to drive more business. And whatever that will be where we're going. And so I don't predict the future, but people who cannot predict it, perhaps they can build it. And so that's what I'm focused on, trying to build this future.
Very good. Well, thanks so much for your time, Marco. It's been great to have you give us a bit of a masterclass on some of the building blocks to what you're making possible. So thanks again.
Thank you, Steve. Mars is a very dusty place, so another one bites the dust. That would be me in this case. Then the second song would probably be "That's Life" by Frank Sinatra, because I'll have to find some motivations for me being stuck on Mars, and that's life, I guess. And then the last song would probably be "Nessun Dorma, Vincerò" from Pavarotti. Vincerò. The one. Very motivational song. To motivate myself when I'm stuck on Mars.
Okay. Do you listen to opera much in the normal course of events?
Only when I'm stuck on Mars.
Okay, all right.